Good morning, viewer. Bindas here. Here's the breaking news. Imagine trying to settle into a new home while constantly being attacked. That's what the bacterium Pseudomonas aeruginosa faces when it infects the lungs, and it cannot both spread and protect itself from antibiotics at the same time. Nonetheless, it's one of the top culprits of hospital-acquired infection, and it's notorious for causing long-standing antibiotic-resistance infection, causing damage, especially in people with lung disease like cystic fibrosis, COPD, or bronchiectasis. To survive tough condition, P. aeruginosa forms colonies known as biofilms, clusters of bacteria encased in a cell-produced matrix that provides them with significant advantages, including protection from antibiotics. But biofilms come at a cost. The clustered bacteria also lose the ability to move around, find nutrients, and spread effectively for P. aeruginosa affecting a lung. This poses a dilemma. Should it spread across the lung surface or bunker down to resist incoming antibiotics? Achieving the right balance can mean life and death for the pathogen, and disrupting it can mean life or death for a patient. New research by the group of Alexandra Peresrod at EPFL's Global Health Institute has now uncovered how P. aeruginosa manages the trade-off between colonizing and surviving during infection by switching between biofilm formation for antibiotic protection and a more mobile planktonic state to spread and accesses nutrients depending on the environmental pressures key phase. The study published in Nature Microbiology. To better understand P. aeruginosa's behavior, the researchers grew the bacteria on mucus-covered tissue models that mimic human lungs. These tissue models, known as organoids, are at the cutting edge of bioengineering. We then used a high throughput screening technique called transposon insert sequence combined with metabolic modeling and live imaging to study how P. aeruginosa adapts to colonize the mucosal surface of the lung and tolerate antibiotic treatment, says Lucas Medelius, who led the study. Thanks to the TN sequence techniques, the scientists identified which genes were important for the bacterium's survival under different conditions, those which contributed to fitness during mucosal colonizations and those which help the bacteria tolerate antibiotics. Beyond this exclusive report.